All right, welcome to the college algebra chapter 2 practice test. So the distance between 2 points is found by the distance formula. So you subtract the x values, you subtract the y values. It's okay that they're going to be negative when I subtract them, because after you subtract them, you square them. And then you take the square root, and that's equal to the distance. So distance is equal to, that would be -5 squared is 25. And that would be -3 squared is 9. So it's the square root of 34, which is approximately 5.83095. The midpoint formula is an average, so we do 1 plus 6. We average together the x values. We average together the y values. Both of those are 7 divided by 2, so it's 3.5, 3.5. Okay, so intercepts first. We do the diagonal 0 trick. Put 0 in for x, figure out y. Put 0 in for y, y and figure out x. So we put 0 in for x, this goes away, and we get 0 is equal to 9y squared plus 8. Subtract the 8 over. Divide by 9. Take the square root. Oops, I'm taking the square root of a negative number. You can't do that. So there's no answer for that. Now I put 0 in for y. That goes away, and you get 2x is equal to 8. X is 4. Now we're going to test for symmetry. So when I replace y with -y, it goes back to itself. So if I have 2x is equal to 9 and then -y squared plus 8, if you square that, you get 9x is equal to 9y plus 8. Y squared, because it's squared. But you're squaring with -y. I plug it in, and it's going to go back to the original formula. So that means that y and -y produce the same thing. Y and -y. Y is up and down, so it's going to cross over the x-axis. So this shows that it has x-axis symmetry. All right, this one here. We're going to put 0 in for x. That goes away. It's going to leave 7y squared is equal to 35. Divide by 7, and you get 5. So y is equal to plus or minus the square root of 5. Because you take the square root of each side to get y by itself. Now we're going to put 0 in for y, and that's going to give 5x squared is equal to 35. Divide by 5, x squared is equal to 7. X is equal to plus or minus the square root of 7. Now, if we replace x with -x, it's going to go back to the same thing. If we replace y with -y, it's going to go back to the same thing, because you're squaring the negative. And since it works with x and y, that means it has origin symmetry too. So it has x-axis, it has y-axis, and it has, if it has this one and this one, then it also has origin symmetry. Okay? Next page. Circle in standard form. So we're basically just plugging the information into the equation here. So it's going to be x minus the 8 squared. It's going to be y plus the 3, because it's a negative squared, is 49. Square the 4, it's r squared, so it's 49. Now we're going to convert it, and we're going to graph it. So we sort it out here. We get x squared plus 4x leave a blank space, y squared minus 6y, leave a blank space, equals 12. So we do half the middle term squared. So that's going to be a plus 4. Half the middle term squared here is a plus 9. Now if you add 4 and 9, right, so you got to add 4 and 9 over here. So if you add it to one side, you got to add to the other one. So the purpose of this was, now this is a perfect square trinomial. So it factors into x plus 2, and then this factors into y minus 3. And then that would be 25. So my center is at negative 2 comma 3, and the r is equal to 5. So now I'm going to graph that. Negative 2 up 3, and the radius is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I just go up 2, 3, 4, 5. I go up 5, down 5, left 5, right 5, because it's easy to count 5 when you're doing that left, right, up, down, because you have the boxes. You know, you go diagonal, it's kind of hard to count 5. Now, do the best you can to make it look like a pretty circle. And mine looks okay, not great. Write the equation of the line in standard form with the center of 1, 0 and containing the point negative 3, negative 2. So the biggest thing with this is you have to be willing to draw yourself a little picture, right? So and the center is here at 1 comma 0, and if I go negative 3 up 2, that would be kind of like over here, negative 3 comma 2. So what I really need to know is I need to know that distance, that radius. So I need the distance formula to do this problem. I know the center, right? The center is your h and k. That's done. So it's going to be x minus 1 squared plus y minus 0 squared is equal to radius squared. Okay? So whatever the radius is, I got to square it. So I got to figure out the radius. So I can use the distance formula. So I subtract the x value. So negative 3 minus 1 would be negative 4. So it's negative 4 squared. 2 minus 0 would be 2, so it's 2 squared. Take the square root. So that'd be 16 and 4. 16 4 is 20, so it's the square root of 20 is your r. So square root of 20 is your radius. Then we get x minus 1 squared plus y, because the 0 doesn't matter, squared. And you square that, and you get 20. So that's the equation. So this equation holds that formula, which is this information. All right, now the variation stuff. So we write it down, right? Z varies directly with x and inversely with y cubed. So you say z, you need some kind of number to hold it together, so you do k, and then x directly, so x is on the top, and then once it says inversely, you make a fraction. Now there's no numbers here, so I can't figure out what k is, the constant. Last question. Beams, right? So a beam has to hold weight, so that's what this is about. The maximum safe load for a horizontal rectangular beam varies jointly with the width of the beam and the square of the thickness of the beam. So the maximum load safe weight, so load is equal to K, and it's jointly with the width of the beams, W, and the square of the thickness, so thickness would be T squared, and inversely with the length L. So it's the length of the beam. That makes sense, because if you have a short beam, let's see, I have a popsicle stick here. So if you think about it, I'm not going to make the popsicle stick shorter or longer, but I could represent that by putting my fingers close together. So if the beam is really short, then it's hard to bend, right? It's not going to bend when it's short. So the length has to do with it. If the beam is longer, then you can bend it, right? And then the thickness, so how thick the wood is, the width of the wood, right? So we have these factors creating how strong it is, the load that this can hold. So we got the thickness, right, T, we got the width of it, and then we got how long it is. So I can represent the length, again, by putting my fingers together, trying to bend it, versus my fingers far apart. Okay, now we're going to plug the crap in and find K. 8-foot beam, so that would be L down here. We got K up here. It can support 750 pounds, so that would be 750. And then 4 inches wide, 4, and 2 inches thick. All right. So this times that. Autumn, get out of here. So this times this is 4 times that's 16. So I have K times 16 divided by 8. So that would be 16 divided by 8 is 2, so it would be 2K. So then that's 2K is equal to 750. So 2K equals 750. So K must be half of that, which is 375. So now I have my equation. The load weight is equal to 375 WT squared over L. So what's the maximum load safe way if the beam is 10 feet long? So now it's longer. So we put a 10 down here. We got our 375 up here. It's 6 inches wide, so that's 6, and our T is back to 2 again. All right. So we have this times that. So it's larger numbers, so I'll break out the old calculator. So we have 375 times 6, 375 times 6 times 2 squared is 4, divided by 10. 900. So it'll hold 900 pounds. All right. Peace out.